So for subtraction, the same vector A minus B is going to be what? 2 minus what? 1. Right? Plus, let's do for the J component. The J component is what? Minus 3, which is here, then minus, which is this sign, then what? Minus 1. Plus, let's do for the K component, which is what? 1 minus what? 3. This is it. 1 minus 3. So at the end of the day, you are left with what? This vector. That's all. Subtraction. Do you understand? Fantastic. Any question? No. So we are going straight to what we call dot product. Dot what? Dot product. Then we'll do cross product. And then in the next class, we will now going to be talking about resultant vectors, projection of vector, then magnitude of vectors. Right? And then we can also discuss the angle between them. For instance, if you have, do you know a vector always have magnitude and it has what? Direction. Is that what we agree? But scalar does not have. In sciences now, you have done that. Do you all agree? Good. So, if this is the direction of one vector, right? Let's say this vector, this is the direction of this vector v1, and we have another vector that is going this way. Are we together? This is another vector, let's say v2. Now, we can have the angle between this vector, we can calculate it. Do you understand? We can also calculate the magnitude of this vector. Do you understand? And then, what is the resultant of this vector? What does that mean? Let's assume these are two tensions, if they are like tension, and I decide to pull them out. You decide to pull this one and pull this one. Where do you think the resultant force, where will be the direction of the whole force? If you hold me here now, hold me here, and two of you decide to pull this way, where will I be going towards? Eh? The center. Fantastic. So the resultant will be somewhere here. Is that also? So after dot product, cross product, then we'll be discussing resultant of vectors, right? We also talk about the magnitude, and then we talk about the projection of one vector on another. Fantastic. Now, why do I want to teach you guys about dot product first? Because that's what you're going to be using when you are calculating the angle between these vectors. Now, for emphasis sake, anytime you are multiplying two components similar direction, this component I dot I, it is the same thing when you're multiplying j dot j. Dot product. What do I say? It is the same thing when you're doing k dot k. And anytime it is equal to what? 1. It's equal to what? 1. Now, any other combination is equal to 0 because they are going to be perpendicular. You know, this is y and then this is x. Right? So, because they are perpendicular, anytime you take the dot product, it is going to be 0. So, what does that mean? It means that y I dot j is the same thing as j dot I, is the same thing as k dot I, it is the same thing as I dot k, it is going to be the same thing as j dot k, it is the same thing as k dot j, it is going to be what? 0. Are we together? It's going to be what? 0. So that if I want to multiply, I took out this vector. Can you give me back this vector? It is what? Is it 2 like this?
Yes.
Is this what we have?
Yes.
Fantastic. So that vector, if we decide to put the dot product of that vector, like say I minus 2j minus 2k, right? Dot product with, let's use any vector we have here. Let's use this one. Pick anyone. Let's use this one. For instance, so we have 2i minus 3j plus k. Please, anytime this is the live section, if this recording stop, let me know. Now, I want to take the dot product of these two vectors, right? It's very simple. It's very what? Simple. Normally, if you are supposed to multiply these two, if they are functions, you must take each component to multiply everything out. Is that not so? So let's do it gradually. So first of all, pick the first one, which is I. Is that not so? So multiply it with what? 2I minus 3j plus what? K. I'm going to pick the second component, which is what? Minus 2 what? J. Going to multiply everything again. 2I minus 3j plus what? K. Are we together? Then lastly we have what? Minus 2k. You should be multiplying what? 2I minus 3j plus what? K. Fantastic. Now, you should not recall this your rule, please. Anytime you want to solve the dot product, always put this rule downward. Recall this rule. Is that not so? So I know that I multiplied by I is what? Is 1. The rule is what? So I have 2. I multiplied by j is what? Fantastic. So this is going to be plus what? 0. Is that also? Good. I multiplied by k is going to be what? 0. Fantastic. This is what? 0. Are we together? What about this? 2j multiplied by 2I is going to be what? 0. It's going to be 0. But 2j multiplied by 3j is what? J and j is 1. 3 and 2 is what? 6. Minus and minus is what? Fantastic. So we have plus 6. Are we together? Minus 2j dot product with k is what? 0. Fantastic. Plus 0. Now similarly, 2k multiplying 2I is going to be plus 0. Is that also? Minus 2k multiplied minus 3j is also going to be plus 0. While minus 2k multiplying k is going to be what? Minus 2. Fantastic. So when you take the dot product, you now add them together. 2 plus 6 is what? 8 minus 2. 6. So the dot product of any two vector is going to be a what? A scalar. This is now a what? Scalar. If you call it scalar, if you call it scalar, is a what? Is a scalar quantity. Do you understand? Is there any problem? Who can do something like this? So in fact, as a matter of fact, I gave you guys two vectors to add, S and T. Can you recall them for me? I gave you guys two vectors, S and T. S and T. Two vectors. Can you recall them for me? The initial one is what? Huh? 3I. So this was 3I minus what? J. What about the T? Is 2I plus 3J. Plus what? 3J. 3J. Fantastic. If I ask you to take the dot product of these two vectors, it's not simple. So it's going to be what? 3I minus J dot product dot 2I plus what? 3 what? J. So this is going to be what? 3I into 2I plus 3j, the second component minus j into 2I plus 3j. Is that also? Fantastic. You now recall this. Please, always recall this in your exams, in your text, anywhere you're writing it. I will now say, since I dot I is equal to j dot j is equal to k dot k is equal to 1. You see this? Then similarly you arrange them. I dot j is the same thing as j dot I, is the same thing as k dot I, the same thing as I dot k, the same thing as k dot j, the same thing as j dot k is equal to 0. If you have written this for me, I will now understand better when you continue your solution. And every teacher will now actually know that you know what you're doing. So that 3i multiplying 2j is going to be 6. 3i multiplying 3j is going to be what? 0. If you don't give me this condition, how will I know? Do you understand? Fantastic. Now, similarly, minus j, if it is multiplying 2i, is going to be what? 0. Is that also? Then minus j multiplying 3i is going to be what? Minus what? 3. So that the dot product of these two vectors is just what? 3, which is actually a what? A scalar. Or a scalar. Whatsoever you want to pronounce. Are we together? Good. Are we together? Do you have any question? So can I move to the next, which is cross product? Huh? Can I move to the next one? Which is cross product?